All right, if you're a data engineer, you know this feeling. The pressure to build things that just don't break. Because when they do, the consequences are real. So let's dive into how we can build data systems that are truly built to last. Okay, let's paint a picture. Imagine you work for a food delivery app. We'll call it Hungry Now. Your big job, syncing all the restaurant menus every single night. Now, what happens if that pipeline breaks? Suddenly, customers are seeing last week's prices, they're trying to order dishes that are sold out, and yeah, they get angry. This isn't some abstract data issue, right? This is a real business problem.
And that really brings us to the big question, doesn't it? How do we stop just, shuttling data from A to B and start actually engineering data products? Products that are tough enough to handle all the chaos the real world throws at them.
Well, the answer, or at least a really good framework for it, is what we're calling K6. And the whole idea is simple. We need to start treating our data work with the same seriousness as professional software engineering. We're not just data movers anymore. Nope. We're building production-grade software, and that means it has to be tested, it has to be versioned, and it absolutely has to be easy to fix when things go wrong.
Okay, so where do we even begin with all this? The first, most fundamental piece is version control. Think of it as the foundation for everything else. It's all about quality and making sure we can work together safely without stepping on each other's toes.
So instead of the Wild West where everyone just pushes code whenever they want, we bring in a disciplined Git workflow. Every new feature, every bug fix, it all happens on its own separate branch. Then you submit what's called a pull request, or a PR, where a teammate actually reviews your code, and only when it gets the thumbs up and passes all the automated checks does it get merged in. What does that mean? No more that sinking feeling when you realize you just overwrote 3 hours of your colleague's work. Phew.
And look, this is a perfect example of how you talk about this kind of work. It's not just theory. This is a real, concrete practice. See how clear and professional that statement is? It instantly proves you're thinking about collaboration and safety. This is exactly the kind of thing you want in your portfolio or to bring up in a job interview.
All right, so we've got a safe way to collaborate. What's next? Well, now we need to build our safety net. We need a toolkit that's going to catch errors before they ever have a chance to impact our customers. And that, my friends, is where testing comes in. Yeah, testing is that safety net. It's this proactive habit of checking our work at every single stage. And the goal is dead simple. Find bugs and fix them early. Why? Because a bug caught on your laptop is cheap and easy to solve. A bug found by an angry customer at 2 a.m.? Not so much. This pyramid is a fantastic way to think about structuring your tests. Down at the bottom, the foundation. You've got unit tests. These are for the tiny, isolated pieces of code. Think of a function that just normalizes prices. We can test that in the vacuum. A step up, you have integration tests. This is where we check if different parts play nicely together. Can we actually pull from that restaurant's API and load the data into our staging table? And then, at the very top, you have data quality tests. This isn't about the code anymore. It's about the data itself. Are the prices positive numbers? Is every menu item's ID there? Basic sanity checks. And again, here's how you talk about it. It's super specific, right? It names the tool, Pytest, and it even throws in a metric, 85% code coverage. This is so powerful because it shows you're not just blindly writing code, you're actively measuring and guaranteeing its quality. Okay, awesome. We've got collaboration, we've got testing. We're invincible, right? Well, no. Things will still break. That's just reality. So the next part of the K6 standard is all about building for resilience. It's about designing our systems assuming they will fail and making them super easy to figure out and fix when they do.
You know what the biggest enemy of a resilient system is? It's spaghetti code. We've all seen it, that one massive 1,000-line script that does everything and is impossible to understand. The K6 way is the exact opposite. We use a modular design. We break our logic into smaller files, each with a single, clear purpose. This makes the whole thing cleaner, way easier to test, and honestly, a new person can join the team and actually understand what's going on without needing a 3-hour lecture.
And let's be real, when that pager goes off at 2 in the morning, good logs are your best friend. They are the single biggest difference between a 10-minute fix and a 10-hour-long nightmare of guessing. It's not a nice-to-have, it's the critical breadcrumb trail that leads you right to the problem.
And this is how you prove its worth. The key is to always connect what you did to the impact it had. This statement is perfect. It connects a technical choice, structured logging, to a real business win. Cutting down the time it takes to find a problem's root cause from 45 minutes to just 12?
That is a massive win, and this is how you demonstrate that value.
Okay, so let's recap. Our code is versioned, it's tested, it's observable. We're in a great spot. But now, how do we actually get it out the door and into production? Safely and in a way we can do over and over again without errors. You guessed it. This is where automation takes the wheel.
The magic here is something called CI/CD, which stands for continuous integration and continuous deployment. The best way to think of it is as an automated quality bouncer for your code. Before any change can go live, it has to run a whole gauntlet of automated checks. And if anything fails, a single test, a formatting rule, anything at all, the deployment is immediately stopped. Only the good stuff gets through.
So let's just walk through what a pipeline like this might look like for a data job. First, it automatically checks the code style to make sure it's clean. Then boom, it runs all those unit and integration tests we wrote. And here's the crucial part for us. It runs our data quality checks as a gate. Only if every single one of those steps passes, does it then build our application into a container and finally deploy it. This whole process guarantees that every release meets our high standard of quality.
All right, I know what you're thinking. This all sounds great on a slide, but what happens when things get real? What does this look like when the pressure is actually on? Well, let's look at a real-world incident and see how all these pieces come together to literally save the day.
Okay, it's 2:10 a.m. The alert fires. The pipeline is down. But instead of panic, our tests immediately tell us exactly what's wrong. A partner changed their price format from a number to a string. Classic. Because we caught this automatically in our own systems, we can patch the code, push it through our safe automated CI/CD pipeline, and the whole thing is fixed in under an hour. And the best part? The most important part? Zero customer impact. The business never even knew there was a problem.
And this right here really lays it all out. It's a tale of two worlds. Without Case 6, you've got people overriding each other's work, bugs slipping into production, and debugging that feels like searching for a needle in a haystack. But with Case 6, collaboration is safe, we fail fast with tests, we find the root cause of issues 10 times faster, and our deployments are totally reliable. I mean, the difference is truly night and day.
And this isn't just a feeling. We can actually measure it. Remember that improvement from 45 minutes down to 12 minutes? That's a 73% reduction in the time it takes to fix a data quality problem. This isn't fluff. This is a hard metric that you can take to your boss to show the incredible value of adopting a real engineering approach. So, for anyone out there building up their portfolio or prepping for an interview, this is the language you need to be using. These I statements are gold. They clearly and professionally prove that you're applying these principles. And notice the specifics. Mentioning tools like Great Expectations or Airflow shows you have hands-on experience. Seriously, take these sentences, tweak them for your own projects, and use them.
Look, at the end of the day, Case 6 isn't about adding extra steps or bureaucracy just for the sake of it. It's the complete opposite. It's about building a strong safety net that allows you and your entire team to move faster and with way more confidence. It's what separates a data mover from a true data engineer.
So I'll just leave you with this one final thought. Your data pipelines, your machine learning models, your APIs, all of it, it is software. So the real question is, are you building it to last? Are you giving it the engineering discipline it deserves so that it doesn't just work today, but so it's still reliable and maintainable years from now?